So the second part of this video is going to be just stoichiometry calculations. So the first thing that we're going to look at is called the mole ratio. Basically what we're doing is just comparing the amount of each substance that we need in the equation. Okay, so let's look at what I mean by that. So these numbers are coefficients in our equations. Okay, this tells us our number of moles that we have to have in the available, basically, in order for this reaction to occur. Okay, so everything is done in a ratio. Just like we looked at the grilled cheese, you needed 2 pieces of bread for every 1 slice of cheese to make a sandwich. Okay, that's a ratio. 2 bread to 1 cheese, 2 to 1. So that's all we're doing here with the mole ratio. We're saying you need 2 moles of hydrogen for every 1 mole of oxygen, right? 1 mole of oxygen for every 2 moles of water. You could even go the other way. For every 2 moles of water, you'd have 1 mole of oxygen, right? Because don't forget there's that invisible one right there. There's other ratios you could write, but hopefully you kind of get the idea. You're just comparing one to the other. We're going to be using this balanced equation, this equation for the rest of our practice problems. So let's go ahead and balance our equation, and then you'll have a chance to write some mole ratios. So I'm going to start here with calcium. Here I have 1 calcium here, 1 calcium here. So those are balanced. Let's look at lithium. I have 1 lithium, 1 lithium. So those are balanced. Here I have 1 chlorine, but here I have 2 chlorines. So that means I have to put a 2 here to balance out my chlorines. Remember, when I do that, not only does it change my chlorines, it changes my lithium. So now I have 2 lithium on this side. So I need to make sure I add a 2 over here for this lithium. Okay, so now we could write some mole ratios. For time's sake, I'm not going to write them down. I'll say a few out loud. So you have 1 mole of calcium for every 2 moles of lithium chloride. 2 moles lithium chloride for every 2 moles of lithium. You'd write them the same way as we did previously. You're just comparing 2 different parts of the equation. So here, and this is on your notes, we have what we've had a mole map. This is our stoich map. Okay, so this is basically, let's ignore this side of the map. I'm just going to mark it out. Let's just ignore it for just a few minutes. Okay, if I look here on this side, I have the same mole map that we've been looking at earlier in the week, right? I can go from molecules to moles using Avogadro's number, and I can go from mass to moles using my molar mass, right? So everything is the same in my mole map. What my stoich map allows me to do is go from something that I was given, okay, to now being able to find the value of an unknown in my equation. Okay, so this is what's going to allow us, say, like if we start with something, what we're given, to help us figure out how much we can produce. Okay, and I'll go ahead and say we're probably not going to look too much at molecules at this point. We're going to focus on mass, because when we're actually performing chemical reactions, we're going to be measuring mass. We're not talking about molecules or atoms, okay? So let's look at this practice. And again, we're using the same equation for all of these practice problems, okay? So we're going to keep referencing back to this equation up top. So let's say I'm given calcium, right? And I'm looking for calcium chloride. It might help you if you do something like this. Maybe circle what you're looking for. That just kind of helps you keep track. Okay, so remember, I have my mole map. If I want to go, or my stoich map, if I want to go from what I was given to what I want, my unknown, right? If I want to go back and forth, then what I have to use is my mole ratio. So I'm going to start by writing what I was given, just like we set up all of our mole conversions earlier in the week. So now if I have moles of calcium up here, I know I need moles of calcium down on the bottom. So how many moles? Well, remember there's an invisible one. Okay, and now I can go to my moles of my unknown, right here. I just look what number's in front of that one. Okay, so I started, let me change the color so maybe you can see. I started here and I went to my moles of my unknown by using my mole ratio. Okay, so now once I solve, I'm just going to multiply the top, divide by the bottom, and I get 3 moles calcium chloride, right? Because my moles of calcium has canceled out. Let's look at another one. And if I'm going to just kind of move through these, if you need to pause to write, just pause the video. So again, same equation, right? I'm going from moles to moles, so I just have to use my mole ratio. So I'm always going to start with what I was given, 5 moles lithium chloride. So that's right here, and I'm looking for lithium. So moles of lithium chloride's on top, so that means moles of lithium chloride's on the bottom. How many? There's a 2. There's also 2 moles of lithium. Don't let this confuse you from when we're going from mass to moles. We always use 1 mole, right? Because this is my mole ratio, I have mole to mole. Okay, so mole to mole. So that's when I'm looking at my coefficients. How many moles of each thing is in my equation? Okay, so I've canceled out my moles of lithium chloride. Multiply the top, divide by the bottom. You get 5 moles of lithium. All right, again, same thing, mole to mole, right? So when I'm going mole to mole, I have to use my mole ratio, call it an MR. Okay, so I've got lithium chloride and I'm going to calcium chloride. So 25.5 moles lithium chloride. Okay, and then since I have moles of lithium chloride up here, I want moles of lithium chloride down on the bottom. Remember, we're always trying to cancel out. So how many do I have? This is my mole ratio, so I'm going to look at my coefficients. I have 2. Remember, I'm looking for calcium chloride, so that's going to go on top. And calcium chloride, there's just an invisible 1. So when I multiply the top, divide by the bottom, I end up with 12.3 moles calcium chloride, because remember, my moles of lithium chloride have canceled out. Okay, so when we go from mole of what we're given to mole of what we are looking for, right, like this, we're always going to use our mole ratio. So we're just looking at our coefficients. All right. So on this one, we're going to add in mass. So remember, we have our moles of our given, mole unknown. Remember, we can go back and forth with using our mole ratio. Now I'm going to add in, right, this other part of our mole mass. Our mole map, remember, we could go from grams to moles using our molar mass. So remember, this whole thing right here we've done before. We've done a lot of this. Grams to moles, moles to grams, right? I'm just looking at my periodic table and adding up my molar mass. all we're doing is adding one extra step right here using our mole ratio. Okay, just because we want to jump to an unknown substance. So I'm going to set it up the same way. 70 grams of calcium. Okay, grams of calcium's up here. Grams of calcium has to go on the bottom. Remember, how many grams in 1 mole? So where am I going to find that? I'm going to look on the periodic table, and it's 40.08. Okay, so my grams of calcium are gone. I'm left with moles of calcium. Now that I have moles of calcium right here, I can jump, okay, to my moles of my unknown. And remember, I'm using my mole ratio. Moles of calcium up top, moles of calcium on the bottom. How many moles? Just 1. Remember, I'm looking for calcium chloride. Moles calcium chloride. How many? Just 1, right? It's invisible. Now that I've got what I'm looking for, I'm ready to multiply the top and divide by the bottom. So it's 70 divided by 40.08, 1.75 moles calcium chloride. Okay. Again, if you need to stop and pause to finish writing or kind of look over it, feel free to do so. Okay, here's another one just like that, right? So we have we're starting with grams, so we're going from our grams to moles, right? This is our given. So in order to do that, I've got to use my molar mass. This is what we've been doing all week. Grams to moles, moles to grams, grams to moles, moles to grams, right? I'm just looking at the periodic table. The only thing we're adding is this step to go to a mole of our unknown. And we're using that mole ratio, okay? Or our numbers in front here. Okay, because we're doing lithium chloride to lithium. So I always start with what I'm given. Because I have grams of lithium chloride up top, it means I'm going to have grams on the bottom. And remember, my molar mass is always equal to 1 mole. That's the definition, the mass of 1 mole. Okay, so how am I going to find that? Well, lithium is 6.94. Chlorine is 35.45. So when I add it up, I get 42.39 grams per mole. My grams have canceled. Moles of lithium chloride on the top, moles of lithium chloride on the bottom. So now I'm here, right? I've got my moles of given. I need to move over here to my moles of unknown, right? So that's where my mole ratio comes in. How many moles of lithium chloride? I have 2. I'm looking for moles of lithium. How many moles of lithium do I have? 2. Canceled. Now I'm ready to multiply across and divide by the bottom. Okay, 0.649 moles of lithium. I believe this is the last one. Okay, notice I'm going from grams to grams. Okay, so let's look here. Grams to moles, right? What am I going to use? Molar mass. Okay, remember this is my moles if I'm given, right? What I have, what I'm starting with. I can go to my moles of my unknown using my molar ratio, right? Once I get here, I can do the same thing as I did at the beginning. I can go to my mass, my grams. How am I going to do that? Molar mass. Okay, so it's almost like we're starting, we're ending the same way that we're starting. So let's take a look. Always start with what you're given. Because I have grams of lithium chloride up here, I have grams of lithium chloride on the bottom. Right? How do I find my molar mass? How do I find my grams? Lithium is 6.94. Chlorine is 35.45. So that equals 42.39. That's what we did earlier. Remember, molar mass is always equal to 1 mole. So I've canceled my grams. Now I have 1 mole. So now I'm right here, moles of given. Okay, I have to use my ratio to get to my unknown. Since I have moles of lithium chloride on the top, I want moles of lithium chloride on the bottom. How many do I have? 2. Since I'm looking for calcium chloride, that's going to go on the top. How many do I have? Invisible 1. Now I'm here, moles of unknown, so I can get to my grams by using my molar mass. So if moles on the top, moles on the bottom. How am I going to find my grams? Well, calcium is 40.08. Chlorine is 35.45, but remember there's 2 of them. Okay, so I have to add that in there twice. So I'm going to type that in my calculator. And I get 110.98. Remember, molar mass is always equal to 1 mole. So now I'm going to multiply across, divide by the bottom. And I end up with, let me do it one more time just to make sure, 30.00 times 110.98. Going to divide by 42.39, and I'm going to divide by 2. So I end up with 39.3 grams calcium chloride. Okay, so that's the last problem for these notes. You do have some independent practice problems to work through, so you can start those now. The answers are in parentheses, so you can kind of see if you're on the right track. If you're struggling, do your best, fill in what you can, and then fill